Hi, everybody. This lecture is for our risk analysis class for Monday, February 20th. There will actually be two lectures for this day, both of which are recorded because, as we discussed in week 5 on February 13th, I'm going to be traveling on Monday, February 20th, and so I will not be available to do a real-time lecture, either Zoom or face-to-face. So we're going to do this lecture instead. So I'll do this lecture first, which is going to be about quantitative risk analysis. And then I will do a second lecture, which will be on qualitative risk analysis. So starting with quantitative risk analysis, I've chosen to talk a little bit about how you would do risk analysis on an oil well. If you were drilling a well in an established area, the types of factors that you would consider when you were going to be deciding whether this is going to be a good risk or not. So the first thing that you do before you do the risk analysis is find some sources that will help you to decide what sort of risks you need to look at. And then you look through those and you make some decisions about which type of a tool you will use. So I have here a document called the Evaluation of Petroleum Reserves and Resources. And this is a document that is put out by the Society of Petroleum Engineers. And it turns out that it's sort of a seminal document. It was written about 20 years ago, but I'm sorry, yeah, the Society of Petroleum Engineers is correct. I thought I said something different for a minute, but never mind. So this is a document that I've put on our Moodle page. It's nearly 140 pages long, so you do not have to read this word for word, but I'd like you to see this as an example of the types of thought that go into the process of evaluating oil reserves. Now, the next tab that I will not pull up right now, but is the next tab that underneath it is a short video called Risked versus Unrisked Petroleum Reserves. This is less than 10 minutes long, and I would definitely consider using this as a model just for the thought process. Now, those of you that are doing qualitative risk analysis, which most of you are, don't get afraid of the numbers, because the numbers are very important to quantitative risk analysis. However, you don't have to worry about that for your particular work, but rather think about this as a guide for how you're going to be able to perform this type of a calculation. All right, so what I've used as an example here, borrowing on those sources that I've shown, just a couple of sources, is an evaluation of a well, a vertical or traditional well drilled in the Williston Basin. This first picture that's on your screen just shows you the extent of the Williston Basin. You can see it extends up into Saskatchewan, a little bit of Manitoba in Canada. And then we have a little circle that encompasses a little bit of Montana and then quite a bit of North Dakota. And most of the action is going on here, but this is the Williston Basin. And often when we talk about the Williston Basin, because the Bakken is a huge play, we sort of talk about those two things synonymously. But what I'd like to point out here is this is a stratigraphic map of the different formations that occur in the Williston Basin. And everything that has a circle by it, a black circle, is something that has been known to bear oil. So and as we go up further, they're younger formations. So in the Pennsylvania period, there's the Amazon Formation, which is oil bearing. And then there's the Otter, or sometimes I've heard Otter and Heath used simultaneously. But anyway, then the Charles Formation and the Mississippi and the Mission Canyon down here in the Mississippian. And these are all part of what is called the Madison Group, but that's not a time period. It has to do with a geographic extent. These are the time periods. You might have heard of like Jurassic Park and so forth. So Age of Dinosaurs right in here, so forth. But we're getting a little bit older. Back here in the Mississippian, we have oil bearing in the Mission Canyon. And then right down here on the cusp between the Devonian and the Mississippian is the Bakken Formation, which is that shale that's producing a lot of oil. Then we also have down here the Bird Bear Formation, the Ducrow Formation, and Dawson Bay Formation. And as we get older, we get down into some Silurian deposits where there's Interlake, Stony Mountain, Red River, Winnipeg, and Deadwood, all of which have been known to bear oil. All right, so when we look at that, the first thing we can see is, or you might think whether, and if you're an oil field person, this is going to be very simple, and I apologize for that, but if you're not an oil field person, it may occur to you there's a lot of places that you can hit oil. And you may wonder how likely is it that you will hit oil in any one of those given formations? And the answer is not very likely. The technology that they're using in the Bakken, which is drilling horizontally, increases the chances of hitting oil dramatically, but the chances of hitting oil in any formation is not, well, the chances of not hitting oil or not hitting oil in economically retrievable quantities is always a huge chance as well. All right, so this is just a really quick curve to show you, this is production time versus oil production in barrels oil per day of two of those formations that we mentioned up above, the Bakken and the Three Forks. And what you see is that they initially come in, this is called the IP, or initial production, is quite high. And then the production drops off very quickly to some sort of a more of a flat state. But the initial production and the shape of this curve are something that you can use to predict the total amount of oil that you might retrieve from a given formation in a given oil well. All right, so here we get to this calculated part. Now, what we're trying to do really ultimately is to decide, is it economically feasible to drill for oil in a particular location? And what we have to base that on is reservoir modeling, or deciding what other wells that are similar to this look like, and then doing a statistical comparison or some sort of a computer modeling process that would allow us to learn more or to make some suppositions about what's going on. So what I've done here is I've simplified this a little bit further, and I'm saying we have this well that we want to drill in the Williston Basin, and there are a potential of 6 different oil-bearing zones that we might hit. Then based on experience in the area and in similar geological situations within the Williston Basin, we know a percent chance that we might actually hit oil in that zone and what the initial production might be. So these numbers, the first 2 columns in this document, are mathematically determined from behavior of other oil wells in that area, or from reservoir modeling, from software that would generate some data. But so in my theoretical simplified oil well, we have a potential of hitting 1, 2, 3, 4, 5, 6 formations. We have a 10% chance of hitting Amsden, a 15% chance of hitting the Heath or the Otter, 20% of the Charles, 25% Mission Canyon, 35% Bakken, and 30% chance of hitting oil in the Red River. Now, since I know that I can make a relationship between the initial production of an oil well and the ultimate number of barrels that I can recover, I have what I could expect if I do hit oil in that oil well, what my initial production or IP would be. So in the Amsden, 100 barrels, the Heath, 50, 50 in the Charles, 75 in the Mission Canyon, 200 in the Bakken, and 125 in the Red River. So here's the deal. If I were to hit all 6 of those formations, and I got those sort of numbers, I would be extraordinarily lucky, wouldn't I? And I'd have a terrific oil well. If I hit none of those formations, I would be extremely unlucky, and I would have just lost a whole bunch of money. So what we do is we risk the IP, or we risk the reserve. So in other words, if we have a 10% chance of 100, and we have a 15% chance of 50, and we have a 20% chance of 50, and so forth, what is the chance? It's not really a number associated with a particular oil well, but statistically a likely version of what a well in this area might look like. So because this is statistics, it's just like putting any statistical function together. This really doesn't have any bearing on a particular oil well. The value comes when we look at a bunch of oil wells and how they all perform over time. And over time, we would expect that our aggregate of however many wells we drilled, would ultimately perform like this in the larger sense. It's kind of like an insurance program where we say an under 25-year-old driver of male gender has X% chance of having an accident in 1 year. Well, that doesn't mean that a particular 25-year-old guy is going to get it, but it means that if you pull enough 25-year-old and younger guys together, that you're still going to make money on the bet. So that's what we're doing here. We're setting up something that will predict how this is going to look so that we can ultimately make money. Now, you may be thinking as well, we're only talking about barrels of oil here. So the next thing we would have to do is to figure in what inflation looks like and how the price of oil is going to vary and some other things. So this is just the first step of a multi-step process. All right. So the equation for doing this, which is a statistical, it's called a weighted average, is going to be the summation of the percent of the chance over 100. In other words, we're taking these percents and converting them to decimals, multiplying it by the IP. So here we take the 10% chance we have of hitting our first formation, the Amsden, convert it to a decimal. So instead of 10%, it's 0.1, multiplied by the IP. And we do the same for each of those other 5 formations, the total of 6 formations. We add together the product of the risk, the chance of getting something times how much we expect to get. And we come up with a value that says, when we add those numbers together, 153.75 barrel oil per day. That is a risked value that indicates how much on a risk basis we could attribute to an oil well when we're doing our economic calculations. Now, once again, this is not based on actual numbers. It's based on it's not based on actual numbers of an actual well. It's based on a statistical probability. Now, there's one other thing that's kind of interesting about this. There's also a chance that we're not going to hit anything. So what is the chance that we are going to get a big zero or a dry hole? Well, the answer to that is when we take a look at our numbers, we say, okay, if the Amsden has a 10% chance of hitting an oil well, it has a 90% chance of not making an oil well. So this has a 90% chance, this has an 85% chance of not coming in, and so forth. So if we take 100 minus each of these, so in other words, 0.9 times 0.85 times 0.2 times 0.25 times 0.35, I'm sorry, got carried away, 0.9 times 0.85 times 0.8 times 0.75 times 0.65 times 0.7, we would get the chance of getting nothing out of this oil well. And those numbers multiplied together is just under 21%. So these are just a couple of ways that we would use risk analysis in a quantitative way to try to get a number. And then ultimately, of course, we're going to try to get what is this oil well worth? And we're going to want to put not only numbers, but the particular kind of a number of dollars. And we haven't even started with dollars yet. All right, so how would I write this up? And this is for you when you are doing your methods section. This is what a methods section would look like for a quantitative analysis. Okay, so first of all, you center methods at the top, and then this just gives you some ideas. It also says, reminds you that we have a template for APA 7 papers. Please follow that. So the first paragraph is an overview of the approach. So what I said here is the methods section details my process for analyzing the risks associated with an oil well. Then you cite the documents that you're using to do this systematic evaluation. This would be very much the same as what you're doing for a qualitative approach. You cite those documents and you just say what it is that you're going to be using, and there may even be a particular section, which you'll see when we're talking about qualitative, that you're going to refer to. So in other words, there may be too much information for you to use everything in those documents. So you have to specify what you're using, and then you have to justify or explain, not really justify, but explain why you're choosing that approach, that focused approach, rather than a different focused approach. Okay, so this is a major heading. If you have a level 2 heading, you have it bold, flush left, and title case off to the side. If you and you should always have two of them. In other words, if you don't have two of these in pairs, you really didn't need them in the first place. It should have stayed under the major heading. If you have to go beyond this, go to the template and we'll show you how to do that. Okay, so the methods used would be a level 2 heading. In other words, I would bold it, I would put it flush left, and I would put it in title case. Okay, so in this method section, you talk about how you're going to do the risk analysis, and then you don't put anything about your particular results or conclusion. That will come next. All you're doing is how you're going to do it, how you're going to approach the problem. Okay, and so in the broadest sense here, the top 10 mistakes made in risk management must be considered in light of program objectives and so forth. In the case of the petroleum industry, and I just go through this document. But if you'll notice, I do not in any way talk about my particular oil well that I want to drill. Okay, I just talk about the documents I'm going to use and how I'm going to go about it. So that's what your method section is going to look like. So even though most of you are going to be doing a qualitative assessment, this will carry over in the form for the methods section. All right, ladies and gentlemen, well, that is it for the discussion of quantitative risk analysis using this example. I will post this to our Moodle page, and right below it, I'll post an example of a qualitative analysis. This is not a risk analysis, but a qualitative method section based on a systematic discussion of methods.